Source-provided libraries are more or less trivial to use. They are just additional code for you to add to your project. Because of this, I won't discuss them any further. Using static libraries and dynamic libraries are a bit more involved, but they have very similar steps. To take advantage of them from the source code, note that C and C++ require functions to be declared in order to call them. Header files are what supply these declarations. When a library is installed on the system, chances are its header files are installed in a place that the compiler already searches. So it's just a simple hash include away. However, if you're using some libraries that aren't installed system-wide, like you downloaded it and stuff, you might have a bundle of header files just laying around to use. The -i compiler flag allows you to specify a directory after it to add a location for the compiler to look through to resolve these hash includes. When you compile or link your final executable, you supply the -l linker flag with the name of the library, not the file name, the actual name of the library afterwards. For example, the M library would refer to libm.a and libm.so, and the PNG library would refer to libpng.a and libpng.so. With this flag, the linker will search for the library file in the /lib and /user/lib directories listed in /etc/ld.so.conf, and directories listed in the ld library path environment variable. If your library isn't installed system-wide, for the command line invocation of the compiler and linker, you can specify additional directories with the -L flag in the directory afterwards. And likewise, when running your program, it searches those said locations, albeit now you don't have a command line option, say for specifying the ld library path variable for your given command to run the program. Here's some examples of compiling and linking against libraries. Note that I'm saying linker flag. Under the hood, the compiler is passing along these linker flags to the linker that gets invoked to link together the final executable and produce the final executable. Due to some behaviors in some compilers and how they handle linker flags and their ordering, you want to put the linker flags at the end of your compilation command. Now that I said that using static and dynamic libraries are a very similar process, you might be wondering how you can disambiguate them in case your system has both a static and dynamic version of the same library. As far as your code calling the library functions is concerned, there's no real need to care whether or not it's a static or dynamic library. This is more of a decision for how the final executable gets packaged up and run. Note how the "l" linker flag doesn't care about static versus dynamic. Dynamic libraries will actually have a higher precedence over static ones. However, what if you want to link against the static one explicitly instead of the dynamic one? For instance, if I want to link against libpng.a and not libpng.so. The -l flag has an alternate mode where if you supply a colon, you can specify a full file name, extension, and all. Lastly, GCC has the -static linker flag. This might not do exactly what you expect. Keep that in mind. This makes it so that GCC only links statically. This can put you in a pickle in case you don't have the static versions of various libraries that you might be using. So over here, I have a program that uses the C math library to perform a sine on 30 degrees to, well, pop out a 0.5 out of it. So let's try building it over here. So I have a main function here. It uses hash include math.h. So this is the header file that gives me declarations so I can call the sine function. So my current C program knows what the sine function is and knows it's around. And then here I define what pi is because the sine function for the CMath library takes in radians. So this is for my degrees to radians conversion. Here I specify that my input value x is 30 degrees, and then I call the sine function, and then do a conversion from degrees to radians by multiplying by pi and dividing by 180, and then printing out the result here. So if I do gcc -o app main.c, you see that it doesn't know, it can't figure out where is the sine function implemented. So to fix that, we can link against the math library, the libm.so library or .a library. When I do this, I'm linking against the math library, the M library, and then I can run my app here. See that does sine 30 is equal to 0.5. So this is doing dynamic link here. So if I do led on app, you can see that libm got linked into the program. So let's try doing a linking against it statically. So to do that, I would do libm.a. So libm is actually a bit weird, at least on the Linux systems, where it actually requires the use of a static version of the C library as well. And if you try to do that, it also kind of pitches a fit on Linux. When I try to, well, here I managed to link it and run it, or link it into an executable, but if I try to run it, it has a bit of an issue here when it tries to actually load the program. And this is actually one of the weird places where -static actually can work. Where if I do gcc -static -o app main.c lm, where I'm compiling, linking against the math library, and also specifying this is going to be a static executable. This will generate a static version of this program where it's taking the C standard library and the C math library all statically into this single executable. We can actually play around with this. I can do ls ltrsh. You can see that this is 792 kilobytes. And if I move this to app-static and compile this more or less normally, and I'll call this dynamic. If we do ls ltrsh, you can see the size difference here. You can see that when I link against all the stuff dynamically, it's only 24 kilobytes. But when I did the full static executable, it jumped up to 792 kilobytes. And that's because when you're linking against things statically, you have to toss them into the executable, and you're not relying on what system library files are around. So just to recap, the math library is a bit weird in that it kind of requires, if you want to go for a static version, you kind of need to make other things static as well, hence the issue here. But with other libraries, you'll find better luck in actually doing the -m:/lib whatever.a. So keep that in mind. This is just a little fun example with something that's probably on your system already.